Hey everyone, it's Tyler from CG Forge. In this video, we're going to cover the blend shapes node, and by the end of the video, you'll know everything you ought to know, plus perhaps even a trick or two along the way. Let's start with a book and this stag candle holder. And what I'd like to do is create some kind of magical effect. Let's say we have some particles buzzing around, and I want those particles to turn into the book, and then I want them to buzz around again and then turn into the stag. This kind of situation is where the blend shapes node really shines. Let's take a look at the final results and then we'll dive into how this all works. Not only that, but the blend shapes node can also make things loop infinitely. So it's definitely something that every Houdini artist should know about. Let's now go into the GeoNet and take a look at what's happening to put this all together. In the network, I have a cloud of points, I have the book, and I have the stag. When I set down the blend shapes node, in order for this to work, I want to start with the thing that I want to transform. So I want to transform this cloud of points, and then in the second input, that's what I want it to transform to. So if I want it to turn into the book, then I'll go right there, and then you go towards the very bottom and turn this up, and just like magic, it turns into the book. But there's kind of an issue here, as you can see. The reason why we're seeing this issue is because when we are blending these shapes together, the way that this works is that the point IDs on the first input need to match up with a point here on the second input. So again, if I go here to the IDs toggle and I zoom in as an example, we have points number 14,169. And the blend shape node is going to try to match 14,169 with a point over here that's also the same number. That's how this whole node works. And anytime that you're having some challenges or problems with the blend shape node, most of the time you're having problems because something isn't matching up properly. So very important that you understand that right off the bat. With that knowledge in mind, we can kind of see how this is working. Over here on the book, we have 16,000 points, roughly, and with our point cloud, we only have 10,000. So what does it do? Well, it matches up the first 10,000 points, and that's what we see right here, based on, again, the IDs that go up to 10,000 on the book. Now, what's interesting about this is if I'm using less points over here than where I'm going to, so this is less than the number of points on the book, I can just rearrange the point ID assignments on the book, and it looks like everything will work just fine. So as an example, if I use the sort node, this node changes how point IDs are assigned. And over here on the book, if let's say I do a random point sort, now when we go to our blend shape node, it looks like everything works just fine, like this. So now let's try making this feel a bit more magical, right? If I did a noise, an attribute noise on position, so I go like this and I change up our point cloud so that it's doing something more interesting. I'm going to say for the range of values, do 0 centered so that it goes both positive and negative in XYZ. That will give us this kind of thing. Let's also turn up the element size a bit, and we can even try animating this by turning on animation. So now we have this sort of thing animating over here. If I then animate this blend parameter, we can still do the same kind of thing. So let's have this go for a couple of seconds. So frame 48, I'll set a keyframe, and then over 1 second, I want it to now turn into the book. So let's do that. Also change the tangents here. So shift middle mouse and then set this to linear. There we go. Now, when I go through this, we can see that we have that kind of thing. which is pretty cool. Now, over here on the book, I can also set down a noise. And this time, I don't want anything that extreme, but I can, let's say, turn up the element size and turn down this amplitude so that we just have ever so slightly a warbly kind of thing like this. Now we have the meat and potatoes for this whole effect. And just with a couple of parameters on the blend shape node, that all becomes possible. What's also interesting is that if we want something to loop, I can just blend shape this to a previous version of itself and get it to run seamlessly. So as an example, let's say that this whole thing is animating, and after about 4 seconds, I want this to turn back to the state it was in on frame 24. Okay, so what I'll do here for the blend shape node is I'm going to have the first input be this, and then for the second input, I'm going to use a time shift. Let's say that I want this whole animation to happen over 96 seconds. So what I'll say is take the current frame minus 96. On frame 96, if I click this frame text here, it's going to evaluate to 0. Then when we loop, guess what? We're back at frame 1. So it goes from 0 to 1. And now we've seamlessly looped this whole thing. Then on our blend shape node, I'm going to set a keyframe at frame 96, take that to 1, and we're going to have it gradually turn into this shape for about a half second. So at frame 84, let's set this to 0. Then also shift middle mouse the text right here. I'm going to spacebar F to frame all of this, highlight it, set it to linear tangents so that we don't have this ease in and ease out animation. Going down here, we'll say flipbook with new settings, RF start, which is 1 to frame 96. Let's go. All right, and let's play this. Just like that, we have an infinitely looping effect, which is awesome. So there you go. With the blend shape node, I've gotten something to infinitely loop. Pretty awesome, right? So then all I do to put this whole thing together is I have not just one blend shape, but 3 blend shapes. We're going to have the blend shape, that's the book. We'll then have the blend shape, that's the stag, as another one. And then we're going to have our time-shifted version here of our noise. So with the stag, I'm going to again use the sort and attributes noise on that as well. So now, if I update channel names from inputs, it detects that extra input has been made. And what I can do is, as I turn this up, it'll turn into the stag, like that. As I turn this up, it'll turn into the book. And all I need to do is just animate all these different things. So if I then bring in the time shift, let's say that this now happens over 140 frames. I'll just go here and say, all right, at 140 frames, that's when I loop. And then everything else I do to keyframe this is just going to happen before 140 frames. After throwing in a few keyframes, we end up with this kind of thing. And the timing of it obviously needs some work, but that's essentially how this whole effect came together. It's also good to know that the blend shape node is very commonly used in high quality rigs as well. If, let's say, you had a face rig and you were to pull up the corner of the mouth, well, that might create wrinkles along the nose. So what people do is they associate a rig control with, let's say, the corner of the mouth, and whenever it moves up, then they turn up the blend shape and it creates wrinkles along the nose. That's another common usage case of this node. But really, again, it's just taking points and making them move towards something with a matching ID. Now, just to be thorough, it's a good idea to understand what all of this is talking about. I showed you the main way in which this is used, but there are specific situations where you might want to consider the other settings here on this node. So let's go over that one by one. Starting at the top, we have the group section. if I select some points here, only those points have the blend shapes apply to them. Everything else is unaffected. Next up, we have the selection index, differencing, and cache input deltas. And they all kind of relate to this idea of trying to make sure that the blend shape works as fast as possible. However, if performance, in other words, how fast this is, if that's your concern, then you should just write this using a point wrangle instead of using the blend shape node. As an example, if I have a point wrangle and I use the lerp function, I can get this to behave just like a blend shape. And just to show you what that looks like, here in Vex, I have 3 lines of code, and with this parameter, we can just turn it up and have our book. But this is going to run faster than any kind of optimization that's happening here in the blend shapes node, so you're pretty much good to not worry about that. The only other thing you might want to know is that with differencing, that is referring to whether or not you can push values past 1. So it continues in the direction it was heading towards, or you can go in the negative direction. You can push things away from the matching points position. That's what differencing is talking about. If you turn that off, you can't do that, but if it's on, you can overdrive the values. The next 3 settings relate to packed geometry. So if we turn this on, by default, it should be everything you need. If something is packed in the first input or in the second, it's going to treat them as shapes. In other words, it's going to still work like this, as opposed to collapsing them down into 1 point. In this case, we don't see anything changing because it just brought everything down to 1 point that is representing this packed object right now, just the centroid. So essentially, if you have packed stuff, turn this on, you're good to go. Another interesting thing about the blend shape node is that you don't have to use it on position. You can use this for any sort of attribute that you'd like. So to demonstrate that, if I have color, I can set the book as red, and I can set the points over here as green, and that will also interpolate between red and green. So now when I go here, there's our green points, and then as it goes down to the red points, we can see that the color gradually changes as well until it's red, and then it goes back to green. The one thing that you have to keep in mind with the attributes is that you want to have the same attribute on all the sources. Otherwise, this doesn't really work. So if I don't have color here on our first input, this is no longer working because I don't have color for both of the shapes. This next one is the point ID attribute. Let's say that you don't want to use the point numbers that are right here. And instead, you want to use an attribute to match up, let's say, a value on the first inputs with any of the other inputs. Well, again, that's where this attribute, or this point ID attribute comes into play. Let me give you an example of that. I'm going to use an attribute randomize, and I'm going to randomize a custom attribute. We're going to call that our matching points attributes. I'll set this dimensions to 1 so that we're working with 1 value, not a set of 3. And then I'll go and say uniform discrete, so that now I have a random value between 0 and let's say 100. Okay, I'm going to set that up over here on the book. So now for each one of these points, the matching points ID right here has a random value between 0 and 100. I'll do the same exact thing on our point cloud. So now the IDs over here for matching points are randomly between 0 and 100. When I go to the blend shape node, I'll take our matching point attributes and set it up right there. Now, instead of using the point number, it'll use the values on that attribute so that when this goes to do its thing, it all goes down to the points that match based on the attribute value. Now, fun fact, this also works on volumes. So with our blend shape here, I can get this working with 2 separate volume shapes. This primitive ID attribute is here to attempt to separate volumes for you. The description is right here in the docs if you can understand what it's trying to say. In practice, it doesn't really work. And if you want to separate out volumes from each other, you should do that before you feed anything into the blend shapes node. So just ignore this parameter for the most part. Then on the voxel blend, this will tell you how you want to blend the voxels. So if we go to the docs, this has a good explanation. By grid index means that they're going to be matched by an absolute voxel number. I think what the docs meant to say here is an absolute voxel size, not voxel number. So don't get that confused with like a point number situation, point ID. I think this is referring more so to the voxel size. And basically, if there's a size mismatch, then it's going to mess up. That's, I think, what the docs were trying to say here. So here's a good example of when these different voxel blends might be better. So here I have by grid index, and as I go from one to the other, we have this, which isn't so ideal. On the left-hand side, I have a voxel size here of 0.05. On the right-hand side, our voxel scale is 0.12. So different voxel scales make a difference here. Now, when you have the different voxel scales, that's when this kind of thing happens. If we change this by voxel position, this will fix our problem, like that. If we middle mouse this, our voxel size here is 0.12, but when we get lower than that, it goes to the higher res version of 0.05. So it does actually switch its resolution when you get close to a value of 1. Once it is 1, then it just goes with the more coarse resolution, or the resolution on the blend shape, I should say. But the moral of the story is that when you're using volumes and blend shapes, mess around with this if you're not getting what you want. And finally, there's one more section here. The blend masking will allow you to use an attribute to help determine how much of the blend shape value that you'd like to have. So the values are down here. They're animated right now. But what I can do is either set from attributes, in other words, override this stuff using an attribute, or I can scale from attributes. So take all of this information and multiply it against, let's say, this attribute value right here. As an example, I have this attribute adjust float. The attribute is called blend shape mix. And if we preview that attribute, on the left, purple is 0, on the right is 1. That's red. So with those values being assigned, if I, let's say, scale from attribute, that is multiply against these sliders, you might imagine that the red areas get the transformation effect, whereas the purple area does not. However, that's not the case, unfortunately. That's because on the right here, we have from each input selected. If I want to just listen to the first input when it comes to this information, I need to say from first inputs. And now when I go forward, that behaves more like you would expect it to. So that's interesting. If you do say from each inputs, also make sure that this attribute exists for each of the inputs. So if I make a copy here like this for everything, now the red sections are going to become that and everything else does not. And if I change, let's say, how this works on the book, now I can, let's say, make it red more like this. With our blend shape, it's going to listen to the book primarily and not really the point cloud. So in other words, it looks at what you're transforming into, and then it uses the attribute there to determine how it should multiply against these values along here. So just be careful about either saying from each input or from the first input. Basically is where you're going to determine this, or where you're coming from determining this. That's what these two things are saying. And there you have it. That is all about the blend shape node. If you enjoyed this entry, then be sure to visit cgforge.com where you can find more just like this. Thanks for watching, and I hope you have a great day.